Hi everyone, this is your lab section. Let's go ahead and see where we find everything on Blackboard, and I will give you a little tour and also help you how to do your pre-lab assignment for the experiment 1. Okay, so you click your lab and then you're gonna go to your Blackboard site and then you hit experiments, and first thing you need to do is you go to your experiments and then you see your lab schedule, and then we know each week which experiment we are doing. And then normally the week begins with a Monday, so I have put down here the Monday dates, but this is applicable for the whole week. Okay, depend on which day is your lab is supposed to be. Okay, and then it says the pre-lab is due at the beginning of the lab, post-lab is due 1 week after the lab. For example, measurements experiment we do in the next week. So your pre-lab assignment due at the beginning of your lab period, and then the post-lab report is due week after, meaning on the day, on the week of September 7th, starting that week, on the day that you're supposed to do your experiment, that is when the lab report due. And that is the same pattern for all the experiments. Okay, and this is the lab schedule, so you can see which week we are doing which experiment. So the next week we are doing experiment number 1, which is measurements. First thing you need to do is you're going to go ahead and click the measurements handout that gives you the introduction and the procedure for your experiment. Okay, it talks about which glassware you use and what is the purpose of this experiment and how are we going to perform the experiment procedure. So you're supposed to read this on your own. Okay, and also it gives you a data analysis, how you're going to analyze the data. At the end of the experiment, you are asked to calculate the percent error. It also talks about the equation. How do you calculate the percent error? For that, you need the absolute error. Absolute error is calculated accepted value minus the measured value. And you see there are 2 bars at the both sides, meaning when you calculate the absolute error, whether it is going to be a positive or a negative value that you get as after you subtract, you always take the positive value. Let's say your accepted value is 100, measured value is 102. So 100 minus 102 is negative 2. But you do not put absolute error as negative 2. Absolute means you take only the positive value. Okay, and then you take that value and then you divide by the accepted value. For our experiment, accepted value is going to be 100, since we are going to see which piece of glassware most accurately contain 100 milliliters of water. So our accepted value is 100 and our measured value is going to be what we're going to get after we perform the experiment and get the data and then do the calculations. Then you're going to get the measured value. Okay, so to find out the absolute error, you use equation 1, and to find out the percent error, you use equation 2, and your accepted value going to be 100. Also, you need this table where you have the temperature and the density variations. You can see as the temperature changes, density changes. So we want to look at from our experiment and the pre-lab assignment, what is the temperature that they are performing the experiment, and we need to get the density from this table. Okay. And then the part 2, which piece of glassware most accurately delivers a stated volume. And again, you can read the procedure and how to do the analysis. And then also it gives you a sample calculation here for you to get familiar with the calculations that are given in your pre-lab assignment as well as your post-lab calculations. So you go through this as well, okay, leisurely, so you will understand how to perform the calculations. Okay, and at the very end, you're gonna see the experiment report sheet. So for your post lab, this is what you're gonna turn in. So where you have to write down the data and then you have to do the calculations. So for your experiment 1, you're going to be turning in this page that you are looking at, and also the next page, this page, as your report sheet. Okay, and the data. So this is the experiment handout, and on a separate piece of sheet I have written down the data obtained from your part 1 and part 2. Okay, so you look at that data and you're going to fill this chart with the data given in the data sheet, and then you're going to do the calculations in these spaces provided over here, and then answer the questions accordingly. Okay, so let me show you how the data sheet look like. So you click this measurement data. Okay, and then for the experiment 1 report sheet, so the data that obtained from the virtual lab is given here, and also I have written down in the calculated results what you're supposed to do in order to get the calculations properly done for these E to I. So the mass of the water is going to be B minus A. What that means is what you have on the row B, 150 milliliter beaker, 163.6528. You subtract it, subtract A from B. So B minus A will give you the mass of the water. And then how would you calculate the volume of the water? The number you get from E, you divide it by D. D is the density of the water. So I have written down here, shown to you how to perform your post-lab calculations. So it should be easy to do that. And then the same thing for the column, second column and the third column, you follow the same calculation pattern. And then you answer the questions accordingly. And for the part 2, also the data given here, and then I also have written down what you need to do in order to do these calculations. So the mass of the aliquot 1 in grams K minus J. K is going to be 76.2884 minus 66.5750, like that. It is the same thing for the other column too, K minus J. Okay, and then you will do the calculations accordingly. Now this is the data part, and also how you're going to perform the calculations. But when you are turning in your lab report, you have to copy this data into the other sheet, which is the measurement handout, which I showed you as the last 2 pages. You write these numbers down in that paper, and also do these calculations and get the answers and write down in the other paper that I have just shown you from the experiment 1 handout. Okay, and before you do that post lab report, what you need to do is you also need to watch the virtual video. Okay, so the virtual lab video is given here with this link. So you can go ahead and start watching the video, and it does not have any sound in it. You can see that how the experiment is being conducted and what kind of glassware you need and what is the process and how you perform the experiment. For example, for your first part, you need a volumetric flask, a graduated cylinder, beaker, and then the water, thermometer, plastic pipette, a balance. All that is showing and explaining you in the written form what you're supposed to do. Okay, it will make more sense to you after you read the procedure and then watch the video. So after you watch the video, then you start doing your calculation. So you have a good understanding about the experiment and what are you going to learn and how also to do the calculations. Okay. And then, so this is about 15 minutes long. Please go ahead and watch the video. And then afterwards, you can do the report sheet. Okay. And now let me show you how to access your pre-lab assignment. right? So remember, the pre-lab assignments due at the beginning of the lab, and then the post-lab reports are due 1 week after the lab. But you don't have to wait until 1 week, but if you get it done early enough, you can go ahead and turn it in. Now, where do we turn in our post-lab report? So you go to this link, post-lab reports, and for the experiment 1, there is a slot here. So you click that, and then you can go ahead and turn in the report sheet. You can combine it together and attach it as a PDF, or you can take a pictures from your cell phone and do that, or maybe scan it and attach it as one document. Okay, so you can turn it in over here. That's how you turn in your post-lab reports. And then for your pre-lab assignments, you go to this link, pre-lab assignments, and then you will see experiment 1 pre-lab, and you click that, and then it will show you the questions in it. Okay, so there are 2 attempts, and I will get your highest attempt. So you will see the questions like this: question 1, 2, 3, 4, like that. Okay, and let me help you to do some of these questions with you guys. I cannot write anything on this one, so let me go to my PDF version so I can show you how to do the calculations. Okay, let's go ahead and open that. So your question 1 is, which type of glassware will not be used in this experiment? You guys can do that. And then the second and the third questions also you guys can do. Let me help you with number 4. Max performed lab exercise 1 and collected the following data for part 1. You should refer to this data to answer question 4 through 10. Now for glassware X. So for the glassware X, which is this one over here, X, it is asking what is the mass of the water. So for the X, mass of the empty glassware is given. Mass of the glassware containing 100 milliliter water given. So then what should be the mass of the water in the glassware X? That is going to be 169.72 minus 70.049. Right? When you do these calculations, you also need to pay attention what are the rules for the significant figures. Okay, now this is a subtraction. For subtraction and addition, we go by the least number of decimal places. So there are 2 decimal places here, 3 decimal places here. So your answer has to be 2 decimal places, not the significant figures. Okay, if you look at the significant figures, in the first figure there are 5 significant figures, second also 5. But doesn't have to be your answer in 5 significant figures in a subtraction and addition. You go by the least number of decimal places. So 169.72 subtract 70.049 will give you answer as 9.671. So we need to keep this in 2 decimal places. So then we have to drop 1. So when you drop 1, the 1 is less than 5, so you're not going to add anything to the 7, which is our number retaining. So your answer going to be 99.67. So when you write down, you're going to write down 99.67, but make sure not to include any units, without units, when you turn in your assignments on Blackboard as the pre-lab assignments. But when you turn in your post-lab reports, you want to make sure that you write down the proper units. Okay, if it is a mass, it has to be in gram, volume has to be in milliliters, density grams per milliliters, like that. Okay, and that's how you answer your first question. And then the second one, again we have to refer to the data given in question 4. What is the calculated volume of water in glassware X? Now for the glassware X, we found the mass. We want to find out the volume. Volume, mass. How can we relate volume and mass? We can use the equation density equals mass over volume. So then the volume going to be mass over density. We found the mass, which is 99.67 grams. And then the density. How do we find out the density? See, we are given the temperature. Remember, I showed you a chart in our handout, experiment 1 handout, where you have the temperature and the density for that particular temperature. So you refer to that table to find out what's the density at 22 degrees Celsius. You will find that's 0.9978. So you're going to divide this by 0.9978 grams per milliliters. So grams to grams get cancelled. So you're going to have your answer in milliliters. So when you do this calculation, you're going to get a number like this, 99.88957. Are you going to write down all these numbers? No. Again, we have to go by the rules for the division and multiplication. So the rule for the division and multiplication for the significant figures is you go by the least number of significant figures, not the decimal places. Okay, so for the numerator, which is your mass 99.67, there are 4 significant figures here, and your bottom number also there are 4 significant figures. So our answer has to be in 4 significant figures. So your 4 significant figures stop here, 99.88, but the number that we are dropping 9 is greater than 5, so you add 1 more to retaining number, which is 8. So your answer has to be then 99.89. That's what you're going to be writing down over here. 99.89. Again, on the pre-lab assignments, when you are turning in, make sure that you don't put the units. You only put the number 99.89. Okay, and then what you need to do for the next one, refer to the data given in question 4. What is the calculated mass of water in the glassware Y? Now the same thing you do for glassware Y. Okay, you can do that. That's going to be B minus A. There are 2 decimal places, so you keep your answer in 2 decimal places, and so that's how you find the mass, which you guys can do now, right? Because I showed you for the column X, so you can do now it for the Y. And then it is asking find the volume. Enter the numerical value of the volume. How do you find the volume? Same thing. Volume would be mass over density. You find the mass. And how do you find the density? Now you refer to the table in the hand experiment 1 document given. At 23 degrees Celsius, the density going to be a different number than 0.9978. That's going to be 0.9975. Okay, so you use that, refer to the table, and you divide it by the density so you can find out the volume. Okay, that's what you're gonna include for question 7. Now for the question 8, you refer to the glassware Z, which is the 3rd column. Now to find out the mass, you subtract A from B, 158.83 minus 59.299. Now see, in this number, when you subtract, so you have 3 decimal places over here, and then you have 2 decimal places over here. So your answer has to be in 2 decimal places when you subtract it. Okay, and then you're going to write down that answer where it says enter the number of grams, question 8, and then you want to find out the volume of that glassware. Again, you're going to look at the temperature. Temperature going to be 22 degrees Celsius. Refer to the density, which is going to be 0.9978. You divide it by the mass. That will give you the volume of the glassware Z. So after you do all these calculations, you will have 3 different volumes for the 3 different glassware. Okay. And then the next question. Based on the results calculated above, how should Max rank the glassware in order of increasing accuracy? In each choice, the least accurate glassware is listed first and the most accurate glassware is listed last. To answer this question, you will need to use your results from above to calculate the absolute error and the percent error. Remember, we learned how to calculate the absolute error and the percent error in our handout. Now, remember, we talk about okay, how do you do the absolute error? So the absolute error is going to be accepted value minus measured value with the 2 bars. So our accepted value is going to be 100 milliliters because we are looking we are going to see which one contains the most 100 milliliters most accurately. So 100 is accepted value and I need to have the bar. So this is the bar that says absolute. Now for the first one, we found the measured value. What was it, that one that we did together? So the measured volume in this case, into the numerical value 99.89. So you take that and then you put 99.89. So this one is for the glassware X. Absolute error 100 minus 99.89. I can do this in my head, but I don't want to take a chance. Let me go ahead and do it. 100 minus 99.89.11. That's correct. So 0.11. It is positive in this case, but even if you get a negative one, so the 2 bars represent that you have to take always a positive value. So the absolute error is going to be 0.11. And then how do you calculate the percent error? Percent error going to be absolute error you divided by accepted value times 100. Remember, this equation you can find in your handout. So the absolute error is 0.11, and your accepted value is 100 times 100, and this 100 get cancelled. So the percent error for the first piece of glassware, which is X, is going to be 0.11. So similarly, you're going to do the same calculation for the glassware Y and Z also. Okay, and then you will be able to rank which one is the most accurate and which one is the least accurate. Okay, the least accurate glassware is listed first. So you will be able to rank them accordingly after you get the percentages. Okay, I hope everybody got it. That's for the first part.